Hey everybody, this is 9.8, the last section in Chapter 9. We'll talk about 9.7 in class. That's what happens when you have an XY term in there in your quadratic relation. But our main goal with this video is to talk about 9.8, which is systems of quadratics. The nice thing about this section is really you should have been able to solve problems like this when you did systems of equations. It's just going to usually involve a substitution. They're a little bit trickier because a lot of times the resulting equation after you substitute is a quadratic, but nothing you can't handle. So let's talk about what's going on here. We've got two shapes. We have an ellipse in the top one because x squared and y squared have coefficients of 4 and 1, both positive but different values. And then we have a parabola because there's only a y squared and no x squared in the second one. So when you solve this, you're doing two things. You're finding the collection of xy points that makes both of the equations true. That's kind of the analytical or algebraic way to solve. And then you're also finding the place where the graphs of these things cross. So how many solutions are we looking for? Well, we have an ellipse and a parabola. So how many times could these cross? Well, you might have a situation like this, where they cross twice, or you might have a situation like this where they cross 4 times, or 1 time, or 3 times. So we could have 1, 2, 3, or 4 answers for solutions to this system. So we'll see which one we get. The directions on the book problems for this section say solve the system, and then graph to confirm your answer. So let's just start by solving the system. This is going to be easiest to solve if we just substitute. Figure out what y squared equals in one of them and substitute that into the entire other equation. So I'm going to say that y squared equals negative 4x squared plus 100 by taking my top equation and isolating y squared. Now I should be able to substitute all of that in here to y squared. So my resulting equation would be 4x minus, and when you substitute in a binomial where a single term was, put it in parentheses because this minus is going to apply to all parts of y squared that I sub in. All right, this substitution idea shows up in math class after math class, and it always seems to be a struggle. Just take your time, isolate y squared, and put it in for y squared in the other equation. So now you'll notice my new equation in blue has no y's in it, which is the purpose of substitution, to eliminate one of the variables. Now if I distribute my negative, I'm going to change both of the signs in the parentheses. Now if I collect like terms and move them all to one side, I get this. I'm going to add 20 to both sides and get minus 80. And now I have a nice quadratic equation that I solve by factoring or with the quadratic formula. So I am anticipating that this is going to factor. So let's see. Start by dividing everything by 4. All right, the right side doesn't change. And then it's going to factor to x plus 5 and x minus 4, which means that x is negative 5 and 4. Those are the x coordinates of the solutions I'm looking for. So remember, I've got a possibility of 1 through 4 answers, or 0 answers. And if I have any, they're going to happen when x is negative 5 and when x is 4. So if I kind of skip ahead a little bit to my graph these on the next page. Negative 5 and 4 are the x values. So far I've determined that somewhere along this line and or somewhere along this line, I'm going to see solutions. This is x is negative 5. This is x equals 4. So now my goal is to figure out the y coordinates that go along with those x's, to find the height of the intersections. All right, so let's take those x values, and whenever you do substitution, you're going to take the values of x and sub them back in and get the values of y. So you can put those into any of the equations above. Why don't I just do, if you sub into where you solved for y squared, that might be an easy way. So let's see, y squared equals negative 4. One of my values was negative 5, so plug in negative 5. All right, so y squared is equal to negative 4 times 25, which is negative 100 plus 100. So y equals 0, which means that when x is negative 5, the y that goes with that is 0. So there's one solution. But I had another possibility for x, which was 4. So let's see what that one gives me. Y squared is equal to negative 4 times 4 squared plus 100. Okay, so that's negative 4 times 16 plus 100. And that, let's see, negative 4 times 16, that's negative 64, plus 100 is 36. So the y's that make this true are plus or minus 6. So when x is 4, I get 4, 6, 4, negative 6. So it turns out that this parabola and ellipse intersect at 3 points, and those are the points that are boxed in. So technically I'm done. I've solved the question. These questions, however, say part B, check them by graphing. So let's go back to our graph, and we will take these two equations and solve them over here. Excuse me, graph them over here. Okay, so the first equation, let me get rid of all this stuff. Okay, now I'm ready. Let's graph the ellipse. This ellipse, if you divide by 100, I'm just graphing this ellipse down here. That's 25 on the bottom. So this is x over 5 squared plus y over 10 squared equals 1. So this is an ellipse that's centered at the origin with an x radius of 5 and a y radius of 10. Now, to kind of aid in graphing, I know that this thing should be going through my answers from my previous page, negative 5, 0, 4, 6, and 4, negative 6. So I can kind of use that fact to find 4, negative 6, should be right there, and 4, 1, 2, 3, 4, 5, 6. All right, so it's kind of cheating to use the answers that I'm trying to confirm in my graphing, but that's okay. Assuming that I haven't made a mistake, which is sometimes dangerous. But there's my ellipse, and now let's graph this parabola. Let's see, if I graph it, let's see, let's see, to put it in the form that we usually deal with parabolas in, I need to isolate the x by itself. So 4x is equal to y squared minus 20. If I divide by 4, I'm going to get x equals 1/4 y squared minus 5. And there's a couple ways to go about graphing that. It's a sideways parabola that's been shifted. I'm just going to do, for practice, the way where I find the vertex and the intercepts. The vertex is negative b over 2a. So that, since my b is 0, my vertex, my k, which is the y part of my vertex, is 0. And h, when I sub that 0 back in, I get negative 5. So my vertex is negative 5, 0, which means that this same point that was on my ellipse is also there. My intercepts, when I want to find, let's see, y-intercepts, I want to set x equal to 0. So I get basically y squared is 20, and y is going to be plus or minus the square root of 20. And let's see, the square root of 20, square root of 16 is 4, and 25 is 5. So this is 4 point something. So if I go up to 4 point something and down to 1, 2, 3, 4 point something, and then I also have my answers to my problem, which are here and here and here, you get a good idea of what this parabola looks like. So not only is this a new section, but it gives us a really great review of graphing conic sections that we've been working on. Okay, so that's a typical question. And, you know, you'll have all different varieties, intersections of circles and hyperbolas and all of that. So we'll just see those as they come. But this is basically how you do it. You do substitution, like we did back here, to find your solutions. In this case, we had 3. And then you graph them to check. And since both graphs went through the 3 points in question, for here and here and here, we confirmed that our answer was correct. All right, so that is 9-8, the last section in Chapter 9. Hope you enjoyed it. Out.